Tutoring. I just read the question that you have, so nothing sort of novel there. Okay, so I guess what it's saying is like they're trying to show you here, like this is what you started with, and it switches places to the right when it's lower in value. So do you see how like from here to here that these switch places?
Yeah.
Because 12 is lower than 32. Okay, so then what happens?
5 and 12 switch, I think.
I see. Oh, so it literally switches those places. I see. Okay, so 5 and 12 switch, and then um
19 and 32.
but why? Why do they switch like that? Because 19 is less than 32?
Yeah, I think that's the whole point. It's just
This is
there's
it's
only you can only do one switch at a time.
only do one switch at a time. Okay. Okay, let me. All right, so they give you a problem to do here. I guess we got to fill that in, and maybe doing one will make more sense.
Okay.
I thought I could follow along with this, but I really don't. I guess I somehow this maybe it's less complicated than I think it is, but you can only switch so those two switch, and then the 12 and the 5 switch, and then the 32 and the 19. But why? Because that's the first one that's smaller. No, 19 is smaller. I see. Yeah, I mean, that's why I don't follow here, but starts with the leftmost array element and switches places with any element to the right, which is lower in value. So, I mean, I guess this is sort of the same. So the 15 and the 87 are going to switch. But then the other ones stay the same.
Yeah.
Okay. So like to me, 42 is less than 87. They should switch. But is that really what happened?
It has to be it has to switch with the one from the left, I think.
See, 12 is less than 32. That's why they switch. And then, but 19 is less than 32. That's why they switch. But the 5 already switches. Because why wouldn't 5 switch? Yeah, I mean, that's why I don't really understand this. Leftmost switches places with any element. Sorry, this isn't to the right, which is lower in value. After each element has compared to the leftmost element. After each element is compared to the leftmost element, the process is repeated with the element that is second from the left. Okay, so I guess like you're not looking at these. I don't know. I'm sorry. I really don't understand what this is. Like these words don't mean anything. I'm trying to follow the pattern here, and I'm not seeing like an obvious thing here. Do you understand it?
I'm trying to, but I just don't. I think I'm just getting more confused.
Yeah. Sorry about moving on. I'm trying to clear off some stuff here. Okay, let me try looking at this again. Okay. Starts the leftmost array element and switches places. Leftmost and switches any element to the right, which is lower in value. Okay. 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 So you look at the 32 and you look for something that's lower in value. So see how the 12 is lower in value?
Yeah.
So those have to switch places, which is why they do here. Okay. Now you look at the 12 32 isn't lower, 19 isn't lower, 41 isn't lower, but 5 is lower. That's why they switch places.
Oh,
Okay.
okay.
So now 5 is, you look and it's not lower than anything. So now you start with the 32.
Okay.
Okay, so I think we can do this now.
Okay, yeah, that makes sense. So
Okay, so the 15, is the 15 lower? That, is there anything else that's lower than the 15? Yeah, the 3.
3.
So the 3 switches places with the 15. Okay. Now 3 is the lowest, so we just start with this one. Is anything lower than 87? Well, this 42 is. So the 42 is going to switch with that.
Mm-hmm.
Okay, so now, is there anything lower than the 42? Yeah, the 19. So the 19 and the 42 are going to switch places. So then you look at the 19 again. Is anything lower than that? Oh, it's 15. So it's 3, 15. You put the 19 here, 87, 65, 42. Okay, and now you start with this 87. The 65 is lower than it, so they switch places. Okay, and then is anything lower than the 65? Yeah, this 42. So 42 goes here, and 65 goes there. Okay, so 3, 15, 87, 19. Is anything lower than the 42? Yeah, the 19. So 3, 15, 19, 42. Maybe it works out here. Nope, looks like we need more room. So anything lower than the 19? No. Anything lower than 87? Yes, 65, 87, 42, and then 42 and 65 switch. And then those are going to switch here in this last line. So 19, 19, 15, 15, 3 and 3. Okay.
Got it.
It does kind of, I would have described it differently, but I think we got it now.
Yeah. Okay.
Okay, so question 2, we'll look at that together here. Let's see if we can make sense of it. These are like useful algorithms, and they are used, like your phone uses this, other things use this. So here it says, this insertion sort algorithm starts the leftmost element and sorts it. The algorithm then expands to consider 2 elements and sorts by placing the new element in the proper location. Okay, so I'm not sure I follow. Okay, so 88 and 76, so they switch places. And then
Yeah.
88 and 34, 34 is smaller than 88, but it knows to push that into the front.
Yeah. So instead of just switching them, it starts doing it by
Yes.
how
So,
big they are.
yes. So we can do this now together on the second one. I think it's pretty clear what needs to be done. Okay, so here we go. So I guess you wouldn't look at so the first two, I guess so the question is do you go to 13, since 13 is solar 67, and I guess it would be 13, 19, 67, then 25, 37, and 50, because the 13 needs to go in front. Normally it would just switch with the 67, the old way of doing it, but now that doesn't work. So now 25 is lower than 67, so it would know to put it there because in the previous position, because it's between the other ones.
Yeah.
And then this one would know. This one seems like we should have done this, but yeah, I don't I don't get this. I mean, basically just rewrite in order.
Mhm.
But okay, well.
All right.
All right, so we got optimization puzzles. Is that the next?
Yes.
Okay. These are almost all certainly on the internet if we struggle here,
Okay.
but let's take a look. There are n people who have heard who each have one rumor. Okay, so that means if there's 3 people, they have heard one rumor. They want to share their rumor with each other by using email. What is the minimum number of emails needed so that everyone has knowledge of all rumors? Assume that each email can only have one recipient, but can contain any number of rumors. Okay, so the hint here is actually very useful. So it's like this. Let's actually label the four people. So A could send to B, A could send to C, and A could send to D. And then B could send to C, and B could send to D. And then C could send to D. Now you might think, well, what about B to A? Well, that's already included in here. And then
Yeah.
C to A and D to A and so on. So that's why there's only 6 needed. This is a combination problem.
Mhm.
And in this case, it's 4 choose 2. Yeah, I think it's 4 choose 2. So that ends up being 4 factorial over 4 minus 2 factorial times 2 factorial. So that's 4 factorial over 2 factorial times 2 factorial. 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. And that gives you the 6.
Got it.
But the question here is for 100 people. So I believe it's 100 choose 98.
Okay.
So the way that works is it's 100 factorial over 100 minus 98 factorial times 2 factorial. So it's 100 factorial over, no, I'm sorry, choose 2. Sorry about that. That changes this to 2, so that's 98 factorial times 2 factorial. So in the numerator is 100 times 99 times 98 factorial over 98 factorial, which cancels out. And then 2 factorial is 2 times 1. So it's 50 times 99 is your final answer on that one.
Okay.
Any follow-up to that or anything?
No, I got that one.
Okay. Euler path. Euler path here. All right, using only straight lines, you can connect the dots in the grid diagram below. Every point should have a line passing through it, starting with the top left corner. Using the greedy approach, you can connect as many dots with one line as possible. It should take 7 lines. Okay, so I don't know. I mean, I guess like, I don't know if that's 1. That's what they mean by that.
Mhm.
2, 3, 4, 5, 6, 7.
Yeah, that makes sense.
Yeah, they show this actually in engineering, like first day of engineering at college. They want you to realize that lines are sort of arbitrary. So like if you have this really faint line that does this,
Mm-hmm.
and then one that comes back like this, and one that comes back like that, you can actually hit it with 4 lines.
Mm-hmm.
And then let me see if I can even do this here. Insert. I guess I don't have oh, I do have a box. So I can also make a box that's a line. If I fill this in, let me see here. All right, well, I can't do it here, but imagine like this is like the line thickness is arbitrary. Imagine this whole thing is a line. Like it's just a really fat marker, thick marker. You could get them all in one shot. I don't really know if that was the intent here, but
Oh,
that's
yeah.
so I don't know. Does that satisfy that question for you, or do you feel like you need something else or different?
I think since it says we can only use straight lines, it has to be like another way to like draw the lines, but only have 6 of them.
Okay, so to me, the greedy approach, like okay, if you assume that they don't have to, like there's 1, there's 2, there's 3, 4, 5, 6. I mean, I don't know if that's what the instructor was intending, where this is 4, 5, and 6. But like the first way I showed you, they all connected. I don't know if that's what was intended here, but
Every point should have a line passing through it, starting with the top left corner. I think they have to like pass through each other, so I don't think that one would work.
well, there's no way to do it in less than 7 is why it says the greedy approach. So
Okay.
maybe I mean the greedy approach would be the max, the minimum number.
Mm-hmm. Um, yeah, I mean, it just says try and find a solution, so it's probably showing that it can only be 7 lines. Like, yeah. Okay. So I think we can move on to the last one.
All right, let's do it. So the incredible egg puzzle. Incredible egg puzzle. You are given 2 eggs. You have access to a 100-story building. Eggs can be very hard or very fragile, means it may break if dropped on the first floor or may not break if dropped from 100th floor. Both eggs are identical. You need to figure out the highest floor of a 100-story building. An egg can be dropped without breaking. Now the question is how many drops you need to make. You're allowed to break 2 eggs in the process. Try to find the best way to test this. Okay. So for example, if you drop 1 egg from the 50th floor, the worst case scenario is that it breaks and you will have to use your second egg to check each of the 49 floors below it. That would require 50 checks.
Mm-hmm.
Okay. Yeah, so like this is one of those problems where like when the answer, you don't actually get an answer, you get like a scenario
Okay.
out of it. So like let me try to explain this. Let's say you drop it from the 3rd floor. Okay, and there's 2 possibilities. It could break or not.
Mm-hmm.
Okay, so if it breaks, let's go down that road. You have 1 more egg. Okay, so you could drop it from the 2nd floor. you could then go to the second floor, and two things could happen. It could either break or not. Okay, but if it breaks, then you know that it worked on the first floor. If it breaks, then you know that the first floor is good. If it does not break, well, you kind of already knew that because you dropped it from the third floor, because it broke on the third. The second, if it didn't break, then you know you're at the best place.
Mhm.
So you don't want to. You actually don't want that. Like that wasn't a good. That wasn't a good one. Let me try this one more time with a different floor. Let me go to the fifth floor. Okay, so let's assume that there's break and not. So if it breaks, which floor would you go to? Well, if you go to you could go to any possible where you could go to the first floor, the second floor, the third floor, or the fourth floor.
Yeah.
Okay. Now, if you test it on the third floor, it could either break or not. If it does not break, but it did break on the fifth floor, what do you know? If you go down this path here, let's say it does not break at the third floor, fifth floor, then third floor. That means that well, we actually don't, we know that we don't know anything about the fourth floor. Like we're not sure if that works or not.
We just know that it didn't break on the first floor, the second floor, I guess.
Yeah, we can then say for sure that 1, 2, and 3 are good. Okay, but if we go to the fourth floor, and we have our choice here if it breaks or not. If it does not break, well, then we know 1, 2, and 3 are good.
Yeah.
But that doesn't help us here because, yeah. So I think we went a little too high on this one. So we're trying to get into a scenario where we know, like, okay, so maybe the instructor wants you to do it this way, where you start from the second floor, break or not. So if it breaks, you need to go to the first floor, and it either breaks or does not. Break, because it could break, not break. But you've exhausted your here. It does not break. You wish you had gone up higher. I still don't. I guess I don't follow. Okay, let's try the third floor again.
Okay.
Third floor. If it breaks, you can go either to the first floor or the second floor. But you wouldn't go to the first floor because the second floor gives you more information. So here, if it breaks, then you know that it's good on the first floor. No, you don't know that because you actually you don't know what would happen on the first floor. I don't know. Why don't you throw this? Actually, I guess I can copy this. I think there is something here I'm not seeing that will make this problem much easier.
Okay.
This one says like you need more eggs. Okay, so the answer here that I'm seeing is you go to the second floor. Okay, and if it breaks, you go to the first floor, and then you either know it breaks or doesn't break. Okay, but if it does not break, you go to the 4th floor. And the reason is if it breaks, well, actually that doesn't help you here. If it breaks, you don't know whether it would have broken on the 3rd. I guess you do. I guess you're supposed to assume that it would also break on the 3rd floor, but we don't know that. I don't know. I suggest we don't spend any more time on this.
Yeah.
But I think you understand at least what they're trying to accomplish here. It's a binary search algorithm, but there's plenty of things on the internet here that suggest like it's between 12 and 14 attempts.
Yeah. Okay.
Okay, so sorry I couldn't be more helpful on that, but we'll tackle this other math thing and see
Yeah.
see if that's any better here. All right, the current annual percentage yield for a savings account is 0.5%. What will be the value of a savings account if you start today and if you deposit $25 every week for the next 10 years? Okay, so this is a future value problem, and you're making a payment. Okay, so we got to go find that formula. I actually don't have it handy. I'm gonna have to look for it, but it's like an annuity, but it's a payment. But you're only getting the savings account is only being done annually. So I wonder, okay. See, again, like I don't really know what the intent for the instructor was here. Maybe they meant for you to get the interest at the end of the year, or if they want you to do it as a payment annuity. These things are never very clear. Okay, so it's the payment times 1 minus 1 plus r to the minus n over r. So r, though, is your interest rate divided by the number of compounding periods. So in this case, your r truly is the 0.5%, it's 0.005, because your number of compounding periods is once per year, I guess. So I think one of the ways we can make this simpler is $25 every week, 25 times 52. I'm not sure what that is. Let me get that. It's $1,300 a year. So it's $1,300 times 1 minus 1 plus 0.005. Now, n is 10 years. So it's minus 10 over 0.005.
Okay.
Right, so I get that it's worth $12,649.54.
Okay.
I really wish I had more clarity. Okay, well, a CD. It's weird this week. I mean, it's not a normal thing to do. I mean, usually you consider things with the time value that you're getting interest rate at. So if you're getting interest yearly, you just consider putting money in yearly. Okay, so certificate of deposit, talk to your mom, don't ever dad, don't ever do that. Those are terrible. They don't give you any return. This is horrible. I mean, inflation's 8%. I mean, that's horrible. So it's the same calculation, but it's 0.014 instead of 0.005. So it's the 1,300 times 1 minus 1 plus 0.014 to the minus 10 over 0.014. So if you got your calculator, you can do a second entry to just get back your previous thing. I mean, this will be a lot better, but it's still a horrible interest rate.
Okay.
Actually, I did. Is this right? 1 minus. I must be not doing something. Let me do this with another calculator because that previous number didn't seem very good.
Okay.
Minus. Rate 0.014, number of periods 10. Payment is 1,300. Okay, so the first one, it was 0.005. Yeah, so I don't like this first number. There's something I'm not doing right up here. This first one is actually $13,296.43. And then the second one is $13,850.34. So a little bit better.
Okay.
Okay, number 3 is a payment. You're calculating monthly payments on this. All right, so you're going to buy a car and you have a $3,000 down payment and you want to buy a $29,775 car. So your down payment deducts from that. So you're financing $26,775 and you have an APR of 0.0386 and your month and you're doing this for 60 months. So we got to find the payment formula for this. See if I can find it. All right, so I guess it's the same formula. So it's 26,775 equals the payment that you're going to figure out here. 1 minus 1 plus 0.0386. But I guess because they're doing this monthly, that's why that becomes minus 12. And then it's minus 60 because that's the number of months over 0.0386 divided by 12. Let me try this, see if it works. Yeah, so the payment works out to be $491.41 on this one.
Okay.
Using this formula. Nobody does it this way. They just use calculators. So it's a little odd. You'd be nice to do this. Finance students do this. I think your brother had some classes doing some stuff like this also.
Lovely.
Yeah. So this is another car payment question. So it says this one instead that you still have the $3,000, but you're buying a $17,000 $990 car. There's also taxes when you buy cars. They always throw in extra things, but that's your loan amount. So that equals your payment times 1 minus 1 plus 0.039 divided by 12, because that's the interest rate. And then it's only 48 months. So that's minus 48 over 0.039 divided by 12. So we'll do another calculation here. And your payment here is $337.79. Hopefully the next question asks, oh, never mind. What's more interesting is if you multiply 337.79 times the 48, you pay so much more than that. You would never buy a car for that amount, because you end up paying like $8,000 more or something in this case.
Yeah.
For it. Okay. And it says now here, okay, like, hey, imagine you decided not to put a down payment on your car. So it's the same thing, but instead of it being $14,990, it's $17,990, because that money you were gonna have, you decided to use it for something else. And that changes it substantially. You end up getting $405.39 payment.
Okay.
I think the issue above here, if you were wanting to do this, is that this is 0.01. I should have done it this way. This should have been 25. This should have been 52, and this should have been minus 520. And this should have been divided by 52, and then it would have worked out correctly. And then same thing up here. This should have been divided by 52, divided by 52, and this should have been minus 520.
Okay.
I think that would, and that's 25 as your payment. Okay. Anything else you'd like to look at today?
Yeah, I have a homework assignment. We can just start working on it. I'm
Sure.
sending it to you now. Okay, that should have just gone through.
All right, checking here. I do see that. Okay, so let me grab this at page 335. Start with question 6. Question 6. Yeah, so this is a right triangle, and you always want to find the missing side. So in this case, B is your missing side, and a squared plus b squared equals c squared. So you've got 6 squared plus b squared equals 8 squared. 36 plus b squared equals 64. b squared equals 28. So you take the square root of both sides. 28 reduces to 2 square root 7. You do want that reduced form there, but that's not the problem. The problem here wants you to find all 6 trigonometric functions. Okay, so we start with sine of theta. That's theta, it's a Greek letter there. Sine is opposite over hypotenuse, 6/8. And you do reduce, so this is 3/4. Cosine of theta is adjacent over hypotenuse. The 2 and the 8 do reduce there. And then tangent of theta, you have options here. It's either opposite over adjacent or it's sine over cosine. Okay, whatever you prefer. So in this case, I don't know, I guess I'll go 3/4 over square root of 7/4. When the bottoms are the same, it just becomes 3 over square root of 7, but then you do need to rationalize. So you get 3 square root 7/7. Cosecant of theta is the reciprocal of sine. So when you got it in a nice form, you just flip it. Secant of theta is the reciprocal of cosine. So depending on what form you have, sometimes you just flip it and then you still got to rationalize it here. So that becomes 4 square root 7/7. And then cotangent of theta is the last one there. So you can flip tangent, and it's better to like go back here and flip this one, not the final one, because it looks nice.
Yeah.
Okay, so that takes care of 6. 13. 13 is next. 13 says the tangent of theta is 5/9. So they don't give you a triangle this time. In 13, you gotta build one. So I'm gonna build kind of the more standard one here. I think this one's a little more standard here. There's theta. Tangent of theta is opposite over adjacent. And again, you got to find the hypotenuse here. So C 5 squared plus 9 squared equals C squared. 25 plus 81 equals C squared. This is 106. So take the square root of that. That's 2. I'm sorry, is that right? Yeah, that's 53. 53 is a prime number, so it just becomes that. Okay, so now we got to find the 6 trigonometric functions. We'll start with sine theta. Sine theta is 5 over the square root of 106, but you have to rationalize, so you can multiply the top and bottom by square root of 106. So that's 5 square root 106 over 106. Cosine of theta is 9 over the square root of 106. So same thing, you get 9 square root 1/6, or 106. Tangent of theta, we already have that one, that was 5/9. And then you got the other ones, you got the reciprocal. So sometimes they're nice. So like this is 9/5, but in the case of these over here, they're not nice. Cosecant of theta, you could flip this end one, but it's better to go back to this first one and flip that because
You don't
it's
have
already
to rationalize it.
exactly. And I'm glad you see that because a lot of students don't, and it's a time saver here on this problem. So instructors looking for all 6, just make sure your answers are clear when you do that because there's a lot of work sometimes for these. 23 looks like okay, so 23 is a unit circle question.
Okay.
So if you know your unit circle, like you get it, there's not really much that I can do other than just draw the unit circle for you to show you. So cosine pi/4 is 45 degrees. It's right there in the middle. That's where sine and cosine are exactly the same. X is the cosine, Y is the sine. So cosine pi/4 is square root of 2 over 2. Not much to do on that. 29. $29 is a calculator problem. So I'll point
Yeah.
out, if you're doing any other classes, just make sure your calculator's in degrees, not radians, your mode, because you will get weird answers here. So let me get this for you. Okay, you get 0.9613.
Mhm.
29, is that also a calculator? Oh, we just did that, sorry. What
Yeah.
was the next one? 31, 33, 35. Wow, these are all calculators. Now, 31, you have to convert from degrees, minutes, seconds.
Mhm.
So this is the cosine of 19 plus 23 over 60. You can just enter it into your calculator that way, and it'll take care of that. So go 19 plus 23 over 60. So I get 0.9433. I'm just arbitrarily choosing 4 decimal places.
Okay.
You can use however many you think the instructor wants. 33 is not degrees anymore. It's in radians.
Oh,
And
okay.
it's not because there's a pi, it's because there's no degree symbol. So
Oh,
notice that in these, there's a degree symbol, no degree symbol. So your mode better be in radian when you do this one. So tangent of pi over 12. I get 0.2679.
yeah, I get that too.
Great. All right. Well, that takes us to the end of our lesson for today.
Okay.
Thank you so much for scheduling us to hear the notes here shortly, and I'll see you next time.
Okay, thank you.
You're welcome.
Do you mind sending me your trig cheat sheet again? I seem to
course.
have misplaced it.
Absolutely. I'll send it in the email.
Okay, perfect.
All right. Have a great night. Bye now.
Thank you. Bye-bye.